Okay, hi, this is Will. One of the things that I've been working on was trying to get the Click PLC working with the factory I/O. Now I know at the summer session Tim was showing off the factory I/O, and I personally think this is one of the best tools that we have. Let me just, and if you haven't, and I'm sure Tim showed it off, but one of the things that we can do with students is, we can dock all these tags, and we can walk through how the program has to run and what functions need to be done without doing any code. The green arrow is where you drop a box in, the red arrows are where they leave the program. This is called the emitter, these arrows are called removers. Now for this program we're dropping boxes. Tall boxes go up in the screen or to the left. The shorter, or not tall boxes, go down in the screen to the right. Now if we look in here, we have, and one of the things we can do is we can turn on the sensors also. And here we have this light array. So as the pallet goes through here, we have a pallet sensor, we have a low sensor that senses low boxes, and high sensor that senses the high boxes. We've got other sensors that show when it's actually going onto this output conveyor. Here's when it's at the output conveyor. This thing called loaded is really important because that tells you when the pallet is in position to be transferred. And what you can do with this program is, if we're starting out our program, is the first thing we need to do is drop a box. So we can force these signals on. And the actuators are the green circles with the vertical line in there, and the sensors are these orange things. When they're dull, that means they're not active. When they're on, or when you can see them lit up, that means that they're sitting active or true right now. And what you can do to force a signal is, if you just click on this actuator, it'll force it on, and you can see the box drops there. Now the next thing to do is get it moving down the conveyor. If you just have the emitter on, it'll stay here forever. So what you have to do is this entry conveyor, you have to turn this on, then you have to turn this off. And it's moving down the conveyor. Now I'm going to stop it just for a second if you haven't seen this. At this point it'll go in here, but we need to turn on this little section of conveyor here, and that's called the load conveyor. So now we're going to have the entry conveyor and the load conveyor on. And so I'm going to unpause it, and now it goes up to that loaded sensor. Now at this point I don't need those conveyors on, and I can take a look at this, and you can work with these orbital cameras to take a look, but you can see that now it's in position to transfer either way. And this is a low box, so it needs to come down in the screen. But students can walk through the program without ever having to write the code, so they know what steps to take. And that makes it really good to learn exactly what you need to do the program before you start writing the program. A lot of times I find that we just start writing the program. If it doesn't work, we just start adding branch circuits on there, and it's not the best thing. So you can write down your roadmap of how you're going to accomplish this, and then you start writing the code afterwards, and it works out pretty good. So up here is the reset, so we can get rid of that. And one thing that I like doing is, you can also have these scenes. You could have this scene, you can make up your own scenes, but one of the things to do and this is a program, this is a simple program, but this would be for a basic PLC course. But for more advanced, you can get rid of some of these sensors. So you get rid of, and I would keep this light array so you can tell if it's low, high. But some of these other sensors, like this loaded sensor, you can just delete this sensor, you can delete these retroreflectors, you can delete the retroreflectors down here, and that way you can have the students not only write the code, but figure out what type of sensor they need and where it needs to be located to actually make the program run. And I was thinking of at a later date maybe trying to make a video on one of the ones that we have and we've used, and it works out pretty nice. So Now, how do we get the factory I/O to actually talk to the Click PLC? Well, what we have and what we know is the Click. Well, first let's take a look at the factory I/O. If we look in the drivers and we go down here, you know, it has a lot of Allen Bradley stuff. It's got the control I/O, which is the internal stuff, which is, you know, I didn't use it before I kind of made the video when Tim was down on the course, but I think that's a great tool. You don't need any type of PLC, and then it has all the Siemens stuff. But now it also has this MODBUS Client and MODBUS Server, and the Click PLC is a MODBUS type device, so it can be either a server or client. But if we look at these, and right now we're showing client, but let me try to get into the server because I just want to show one little aspect of that. So if we look at the server, and these are the tutorials from Factory I/O, you can see this looks kind of like what we want for an interface to a PLC. We've got the inputs over here and we've got coils over here. And that was the way I originally attempted to do this, but it didn't work out too well because right here for the, you know, the port number, this port number right here is read only. And the problem I was having when I was first going through it is it was trying to read my actual IP address of my computer and not the hardware IP address of, you know, the actual PLC. So it seemed to me, and what I could figure out is that would be, it was trying to talk to, if you had simulation software on your computer, that this would be the way to go. But I could not change, and it's read only, so I couldn't change it, and I couldn't find any way around it. So I went to the client. Now the client, this offers no help either here because it's got the coils on the input side and the inputs on what would normally be the output side. It's kind of reversed. And that led to a lot of confusion on my part, but that's sometimes typical. But one of the things you can do is you can change these on either side to be inputs or coils. So even though it's inputs on the output side, I can change those to coils. And this whole part of what the coils are, and also they have offsets for the coils, because right here if you had coils on both input and outputs, you'll have coil 0 here and coil 0 there. So you've got to offset the side on the inputs from the side out of the outputs so they don't have the same coil numbers. And what it turns out with, and let me show you also our addresses here. So our entry conveyor, and if we look at the factory I/O, if we look in the view here for our driver, the first output is the entry conveyor. Now we had to give it an offset of 16384. And where that comes from, if you remember, and if you've been working with the Click PLC, this is C1 as far as the coils, as far as the Click PLC is concerned and how you write the code. But if we look in our address picker, and then we go to, and this is a great tool with the Click PLC, is it says, okay, display the Modbus address. Now this Modbus address is 16385. So that's where we get the offset. Now it's not exactly the same because we have 384. And the best I can figure out is the coils for factory I/O start as 0 and move up. The coils for Click programming start at 1 and go from there. So you have to have that offset of 1 in the numbers that you're using, and that'll work out pretty well for you. So what we have is this is our actual C1 in our Click PLC code, C2, C3, C4. Now over here, because these are offset by 50, this is actually C51. So if this is C1, this is an additional 50. And so we have our output coils, the first ones, and then we have a series of internal coils that we use internal to the program. And we had a little video for the control I/O that kind of operated off of all set reset flip-flops. Now what we have here is just regular seal-in circuits that run all the way through the program. So for instance, when we're turning on the entry conveyor, this C1, when we get an emitter, we turn on the conveyor, we seal it in with that entry conveyor, so the output seals itself in, and it'll stay that way until it gets to that loaded sensor at the end of that short little conveyor section that we just saw the box go to. And so these, even though these look like seal-in circuits, these have the same functionality as those set reset flip-flops in the control I/O. So the emitter would set it, the loaded signal would reset it. And we just walk our program down through. And when you see, and when you force the signals on, you realize what signals turn on an actuator and what signals turn it off. And so, you really see very simple logic on each of these rungs. There's not a lot of branch circuits, other than we have seal-ins here, but that's the way we go, and we go all the way down and we step it through. Now, one of the things that we can take a look at if we go back to the viewing, and I'm kind of giving away the keys to the kingdom here, but if we dock all the tags, we have some of these left entries here are normally active. And the reason for that is sometimes, and I guess I'll just drop a box and bring it down here too. I'm going to force the emitter, it drops the box, then I'm going to turn on the entry conveyor. And I'm going to turn this off and going to run it down here. Now, sometimes, like right here, we're trying to figure out what type of box it is. So we're interested in this front edge. So we're looking for the rising pulse. When that pallet goes through those sensors, we're looking for the signal to go from low to high. Now, some of these others, and you can see them in yellow, these at signals, these are normally high, and when the box goes through here, it'll go low, and when the box fully passes, it'll go back high. Again, we're looking for the rising edge because, when we're looking right here, we're interested in the leading edge. These ones that are active high, we're actually looking for the trailing edge of the pallet. We want to know when that end of the pallet has gone past the sensor. So for all of these, we're looking for the rising edge. And having said that is, so right here what we're looking for is we're looking for rising edge triggers. And if you remember from turning on the stepper motor, we need all our commands being edge triggered. And in general, it's a good idea to put all digital signals through edge triggers, but here it's really important for these signals that are normally high, because we're looking for the trailing edge. We need to look at the positive transition of those signals. And what we do for those signals is we just drop the at signal, and in our logic we're using left entry, left exit, right entry, right exit. So we're looking for signals that are just going to be high for one scan. And here's right entry, here's left entry, and they kind of walk all the way down, and that's what turns off our transfer mechanism or our conveyor mechanism. So, and I'm not quite sure what state the PLC's in, so I'm going to reload it. So I'm going to run the project, and this will just start us anew, because I'm not sure where all the outputs are at this point. So the transfer is complete, and we'll go into run. We look for this cyan to make sure that we can see the visibility on each of the gates. Now I'm going to turn off the force there. I'm going to go to our reset, and I'm going to clear our sensor tags, and I'm going to clear all the dock tags. Now what we got here, we're going to start the program from here, and take it off pause. It should automatically drop a box and start processing. Again, tall boxes go up, small boxes go right. So let's see what's going to happen. Oh, and one of the things I didn't do is when explaining this, I got to connect up. So it connects up when we get the green check mark here, we're ready to go. So now let's see. So this is a tall box here, so it's going to go up in the screen. And the idea for this program, or at least what we have, is it processes one box at a time, and when it fully is removed, then a second box will appear. So when it's gone, now we get a second box. And this one's also tall. And also, the way we want it is conveyors turn off when they're not in use. So now this conveyor is not used, this conveyor is not needed, so those go off. Now, and again, it's really hard to take a look at these dual screen, but one of the things you can do with Factory I/O, and it's another really nice thing with it, is if you go into your drivers, and if you turn on the eyeball, it kind of gives this translucent thing. So right now, only the conveyor left is on, which is what we want. And right now, the entry conveyor is on, and then when it gets up here and it recognizes the pallet, the load conveyor is going on. When it gets to this sensor, they turn off, and now we're transferring. And so that's what we want. And what we didn't want is we didn't want that second box. There's something wrong with the code here. So let's take a look here. But so we got a small box here, and that seemed to work. I'm not quite sure what happened. Oh, so we got another box here when that just passed through here. So it shouldn't have had another box until here. So the code is wrong. So let's go backwards for a second. And another thing I wanted to show here is we should also count how many boxes we're processing. And I wanted to show that for the click, but let's take a look at what our program is here. So what happens is when we fully process a box, we have a second box that comes out, and the second box is when we hit this exit signal. And I can see this exit signal, one I have the exit, and the other one I have the entry. And if we look at this, the entry sensor is here, the exit signal is all the way at the end. So I need to change this guy to be the right exit signal, and that would be 19. So I'm going to stop this for a second, reset it, and reload this program. And while I'm at it, I might as well show. So we don't have the counter working. And one of the reasons for that is we have these Modbus addresses that we have to use based on here. And right now it says that we should be at 33 boxes. Now that number is stored in CTD1. So it's the counter, I'm not sure what the D means, but you know, it's a real-time count. But if we look at the address picker for this, CTD1, it has the Modbus address of 449.153, and really we can use, because the 4 just signifies that it's a data bit. So we can put in 49153, and if we take into account the offset, it'll be actually 49152. So if we go in here and we say into our drivers and then go into the configuration, and the configuration is where you put in these offsets. But if we tried to put in that 49152, the Factory I/O would choke on it because it only goes up to 32,768 in its format. So what we need to do with this click programming is we need to put something, and I'll put it, I guess, right underneath here. We want to add a rung. So insert rung afterwards. And what we need to do is copy. So I'm going to copy what's in there. It's in CTD1. And we're going to put it into DS1. And DS is just a register. And that's where we store all our constants and all our variables. So we're taking this and we're putting it from there into here. Now, if we look at what address DS1 is, and we're looking at the Modbus, it has an address of 40,001, but because it always knows that 4 is a register and we're looking for the register, what we can do in our configuration, and we need to get back to our client, is instead of putting in that big number that we were trying to put in before, we'll just put in 0. Because again, even though DS1 has address 1, we have the offset because the factory I/O starts at 0. So if we go back here, and if we go redo the program into the PLC, and rewrite it into the PLC, we should see that be the actual value. And now I've also, well, I didn't actually change that one. I need to change that. So I need this one to be the exit, and we said that it was going to be 19. Excuse me. So now we've got both the exits and we've got the box count. So if we load that, and we'll write this into the PLC, now it should work fine. I didn't realize that I knew about this count, and I just wanted to show that in case anybody was trying to work with the Modbus address, because the Modbus addresses for the normal data words are too large. But if we transfer it into, you know, this DS register, then it'll be fine. So if we go back to here, and I guess I'll reset this and start from the scratch. And connect up. And we have the 35 that we had in there. So in our program we have 35, 35, and now if we look on our factory I/O, we have 35. So we can start it up here. And the way it is if I hit this reset, it's going to go back to 0. So now when we see a small box, everything should be fine. So we aren't going to see the box appear until it fully is removed. Now another thing you could do is you can turn on the emitter so it's just dropping box after box. Now factory I/O kind of self-regulates, and here when this passes here, we're not going to see another box. That's what was the problem before. We aren't going to see a box until we see it fully disappear. Now we got another box. And we also have our count. But one of the things you can do is you can have the emitter always on, and then it's going to drop box after box. And that's a little more complicated logic for some of your better students. You know, it's not much harder, but there's a little trick. Well, it's not actually a trick. I mean, it's logic that's in addition to what you have here. So it makes it more of a challenge. But anyway, that's how you hook up the Click PLC with factory I/O. And again, we've always used this with our Allen Bradleys and our Siemens, and but now that we know how to use it with the Click, you know, anybody who's using with the Trainer, I mean, I know the factory I/O costs money, and it's a pretty good amount of money, but this is a really great tool, and I think it's one of the best things for, you know, sitting down and walking through what needs to be done with the program before you just start writing code. And it makes you think about what needs to happen as far as what signal turns on an actuator, what sensor turns it back off. And you know, if you do that, you know, you come up with really clean logic. And you know, this is kind of what we want to see with the logic. You know, we don't want to see, and you know, everything has one rung, but this second rung and all these rungs are just a sealing circuit, and that's what you do. But you don't see a whole lot of extra branch circuitry in here at all. And that's how, you know, good clean code, you know, you want to see it cleaner. It's easier to troubleshoot. It's just better code. So anyway, that's the little view for Factory I/O with the Click PLC. But now that we've got it working, and again, somebody can take a look at this and say, ooh, you know, and if somebody could figure out how to get that server working, I'd be interested in knowing. But you know, that's what we got for right now. And take a look at it, see if you can get it running. It's good stuff. And again, you know, if we go in here and let me just stop the program here. But if we go in here for the scenes, and I'm sure Tim showed this, but you've got all these scenes, and some of them are basic, like this one is basic. Some of them are a little more difficult. Same thing, a little more difficult. Some of them, like this automated warehouse, that's a challenge. There's some other things like some of these pick and place machines, they're challenges too. And you know, you can make your own scene too. And a lot of these you can just take a scene, and if you want to start with your students, just get rid of the sensors that are in there, and so let them decide what sensors they need, where they should be located. And that's also a really good challenge. So give it a try. It's good stuff. Thank you.